Hello, good afternoon. My name is Desai Daniel John, and today I am going to be talking about time series data, and I'm using R to make analysis in time series data for time series data. The objective of this project is to analyze the J17 dataset, the Comal dataset, and the San Marcos dataset. For the J17 dataset, we have a daily reading of water level. For the Comal dataset, it is the discharge, and for the San Marcos, is also the discharge. And in order to do this, I will have to create a zoo object, which I'm going to show you in a short while. I have to perform an interpolation to replace missing values. I have to perform a 10 days moving average to cater for the fluctuation in for spikes in data readings for, and then I'll have to do a monthly average. I have to perform an autocorrelation and partial autocorrelation of each data set. I have to decompose each data set for further analysis, and then I also have to perform a cross correlation across data sets. So the J17 data set is from 1932 to 2023. It gives the water level daily water level reading. The Comal data set is from 1927 to 2023. It gives the rate of discharge. And the San Marcos data set is from 1956 to 2023. This is to 2023. And in order to perform this analysis, I had to extract the data set, and I had to impute the data set into R and extract the date for this data set, which I'm going to use to create my zoo object. And to do that, I use these lines of code here and put it in a p.x data file. Although this is just the code for the J17, similar code too was used for Comal and San Marcos, and I made changes where needed. And after getting the date for the data set, I was able to check for missing values. If I did get missing values, the program was written to print missing values. And after doing that, I actually did get a couple of missing values that you can see here that you can see over here at the right corner. I did get a couple of missing values. So in order to properly use this time series data, I had to create a zoo object. A zoo object is a type of data structure in R that is used to represent ordered observations of one or more variables over time. It makes use of the zoo package. A zoo object is essentially a time series that consists of two components: a vector of observation and an index vector that specifies the time of each observation. The zoo package also provides a wide range of functions for time series analysis, including the data alignment, merging, and aggregation, as well as missing values imputation and visualization. So as we go on, you will see how I made use of these functions. Here I did the interpolation to impute missing values. After I ran the zoo objects, after I checked for missing data, I saw that I noticed that there were a couple of missing values, so I was able to run an interpolation to replace this missing value so that I can do proper analysis. And this here you can see a nice chart of how the data of water level for the one up here is the one for J17. In the middle here we have for Comal, and at the down here we have for St. Marcos, and that is the trend that I used throughout this presentation. And then we also have a summary of the data set, the mean water level, the first quarter, that's the minimum quarter water level, the first quarter, the median, the mean, the third quarter level, and the maximum. So the same thing too, same summaries to go for discharge rates for Comal and St. Marcos. So this shows how the observations over the years from the start time to the end time. It shows. After replacing the missing values, I was able to do a 10 days moving average. This is to cater for sudden spikes in readings. So I was able to do using this code at the corner here. I was able to do the 10 days moving average. I was also able to get the summary for these data sets and get a plot of how the observations are distributed over the years from start to end. After this, I was also able to do a monthly average using the month of January. This is the code that I use in running the monthly average. I was able to get a nice trend too for how the observation for the monthly average went. This is the first one here is for J17. Here we have for Comal, and at the end here we have for San Marcos. And these are the summaries of all the observation values: the minimum, first quarter, median, mean, third quarter, and the maximum. Then I was also able to perform the autocorrelation. Sorry, let me go back. I was also able to perform the autocorrelation to just to get a feel of this how the values are. And we can see for the J17 the autocorrelations are actually very high. We can see for Comal we have a very high autocorrelation, and then for St. Marcos same thing, two goals. And then after that do I was still able to perform the partial autocorrelation for J17. This is how the plot is, and these are how the trend of the observed values go. And finally, this for the individual data set, this was the last thing I did for individual data sets, which was to decompose each time series and actually just try to see what how the trend for each data set goes. So here on the top here we have the observed values. This is the trend of the observed values. Here we have the actual trend. This is how the data sets actually goes. Here we have a very low water level reading at this time frame, and it just goes on like that. Here we have the seasonal trend, and then here we have the random, which I take to be the noise. So the same thing too goes for Coma. I was able to decompose the data set and get how the trends are, the seasonal, and then the noise too. The same thing too for St. Marcos. And then finally, at the end of the day, I was very interested in running a cross correlation between J17, Comal, and San Marcos. In order to perform this cross correlation, I had to make sure my data sets were in the same time frame. San Marcos had the shortest time frame, which was from 1956. So I had to set my zoo objects for J17 and Comal to be in that same time frame so that I can perform a cross correlation among these three data sets. It's very important to do this. It is very, very important to do this. So after setting the three data sets in the same time frame, then I was able to run a cross correlation amongst the three data sets. This is the code that I use in writing it in the corner here. And these are the charts of the correlation between the J17 and Comal, the J17 and San Marcos, and then Comal and San Marcos. So this is how the correlation goes. We can see that for the J17 and Comal, we have correlation as high as in 0.02, which is actually not that high because the correlation goes as high as it goes from 0 to 1. A value of 0.2 is not too high. Yeah, but there's some sense of correlation in there. And then we can see how the correlation as time goes on, it's it kind of goes way back down again. It comes down to about 0.04 minus 0.04. Same thing for St. Marcos, it goes as high as 0.02, and then it starts dipping back again um, in front. And then for Comal too, you can see how it's not kind of different from J17 and San Marcos, and also different from J17 and Comal. Comal and San Marcos actually has a different trend too, so you can see how unique these data sets actually correlate to each other using these plots. Thank you very much, and this would be the end of my presentation.